Hello students, today we're going to start solving systems of equations. We're going to be focusing on doing it by graphing. Please don't forget to take notes as you go and complete the survey that follows the video. So before we get into it, first we want to go over what is a system of equation. A system of equation is when you have two or more equations using the exact same variables. When we're solving these, the solution to the system is a point or coordinate that satisfies all of the equations. This point will be an ordered pair. So we're looking for an x and a y value in order to represent the solution to our system. When we're graphing, there are three different possibilities that we can have. The first possibility we can have are intersecting lines, such as this graph here. When we have intersecting lines, the point where the lines intersect is our solution. And as you can see from this graph here, the lines only cross one time. Therefore, if the lines cross, there is only one solution. In this specific example here, they're intersecting at the coordinate 1, 2, because you can see on the x-axis it is above 1, and on the y-axis it's by 2. So our coordinate here is 1, 2. So the solution to the system is the coordinate 1, 2. The second type that we can represent, or that we can come across, are parallel lines. So looking at the example on the right-hand side, these represent parallel lines. These lines will never intersect. Since the lines will never intersect and solutions are points of intersection, we will have no solution. Parallel lines will always have the exact same slope, but they're always going to have different y-intercepts. So for example, in this one here, the top line has a slope of going up 2 over 1, so it has a slope of 2 over 1. And you can see the exact same movement of the second line. It's going up 2 over 1. However, looking at their y-intercepts, the top line intersects at 2, and the y-intercept of the second line intersects at -1. So the slope for both equations is 2 over 1. However, the y-intercepts are 2 and -1. So these are parallel, and they have no solution. The last situation we can have are coinciding lines. As you can see, there's a blue line on top of a red line. These are the exact same line. When you have coinciding lines, this is a situation where we have infinitely many solutions. The reason we have that is because the coinciding lines have the exact same slope and the exact same y-intercepts. So in this problem, you can see they both have a rise over run of 2 over 1. And they have the same y-intercepts of -1. That means every point that's on one line is going to be the same point on the other line. So that is why we have infinitely many solutions. So again, intersecting lines have one solution, parallel lines have no solution, and coinciding lines are the same line. They have infinitely many solutions. So let's take a look at an example here. We want to identify the solution of the system that's graphed here. Now tomorrow we're actually going to go through and graph these, but our point of intersection is found right here. What we want to do is identify the x value, which matches up with 2, and our y value, which matches up with -2. So the answer to this problem here is 1, 2, -2. Keep in mind that when we do these graphs, it's like we did before, where we're graphing in slope-intercept form. The first thing we do is graph b, which is our y-intercept, and then m, which is our slope for our rise over run, to graph a couple of points. Then from there, we want to identify our points of intersection. Don't forget, you can always make a table of values and graph that as well. We will be practicing these tomorrow, so make sure you're coming prepared with your notes as well as with being able to actually graph a line. Make sure you complete the survey that follows the video and bring your questions to class or enter them in the survey. We'll see you tomorrow.